All right, so let's try number 39 and 17.3, which says a plot of the vector field G of x, y, and z is f of 2x, y, and z. So they've told me what G is. You just double each coordinate from f. And they say you can obtain that from the plot of the vector field f. Okay, so apparently I have a plot of the vector field f. It looks like, I don't know, something, right? And they say that I can get a plot of G by just doubling the length of all the arrows. So why not? Why or why not? Like, if G is just double the x, double the y, and double the z.
I think your magnitudes would be the same if you doubled it, but your slopes would be different. Like at 1, 1, it would just be a 1, 1 slope. But if you had 2x, 2y, it would be a 2, 2.
Would the magnitude be the same?
Maybe not.
Yeah, maybe let me think about function-wise, what am I doing, right? If I wanted to double the magnitude, like, okay, let me just start with two other vector fields. So like, say I have a vector field K, right? I don't know what the hell the vector field F looks like, so let me just assume I have a drawing of the vector field K. If I doubled the magnitudes of all these vectors, right? So I just went through and I was like, okay, same spot, but I'm just going to go through and I'm going to make all the vectors twice as long. I'm going to call that vector field H or something. How do you get that out of K? What did I do? What did I double?
Double the magnitude.
Yeah, I doubled the magnitude of every vector, right? Did I move them?
No.
No, so I doubled not the... Which kind of thing am I doubling? K takes points and turns them into vectors, right? Which thing did I double? Did I double the point or did I double the vector? I doubled the vector, right? So I did this. I did H is 2 times K.
Okay, so the 2x changes.
You guys with me? So this 2 modifies what you get after you do the vector field thing. Right? So really this is H of x, y, and z is twice K of x, y, and z. Right? You didn't change the point, you changed the vector. What's this thing doing? That's changing the point.
It's like 2f of x.
So instead of a, do you guys remember these? Like if you do f of x is 2g of x versus f of x is h of 2x. You guys remember the shifting rules for these? Flip those. So this one's changing the y's, right? That's a vertical stretch. And in algebra 2, you'd be totally, absolutely correct. That's a vertical stretch, right? But you guys know enough about functions to know that really what that's doing is that's an output stretch. You guys all good with that? So what's doing h to 2x? That's an input. Yeah, that's an input compression. You guys see that? So what's this thing? Which category is that? Is that an output stretch or an input compression that they asked me about in the beginning? Yeah, that's some kind of input compression thing. That's not going to change how long the vectors are. It's just going to change where the vectors happen.
Is that still affecting the height though? Right?
Oh yeah, it's going to change the lengths of the vectors you get, but it's not going to change them by any kind of predictable, it's not going to change them based on what they are at the point you're looking at, x, y, z. It's going to change them based on what their values are at a half x, a half y, and a half z. Right? That's in here. You guys see that? Right? It's stretching or compressing compressing the input plane, not the outputs to the vectors. You guys see that? So what's wrong, right, is this thing is a change in the input plane, not the output vector field. Cool with that? Yeah?